Hello friends, my name is Rahul and this is part 2 of the video series wherein I'm going to talk about DNS protocol. In the part 1 I've covered DHCP protocol and showed you how to decode DHCP packets using wireshark utility. So what exactly is DNS? DNS protocol is used to convert the domain name into an IP address. If you recall my the first video wherein I showed the Wireshark capture, you must have noticed there is an IP field there, right? So IP field typically requires an IP address. It cannot use the domain name. So essentially, we need to convert the domain name into IP address so that the google.com can be accessed, right? So that is the job of this DNS protocol, to convert the domain name into an IP address. Let's take a step back. Let's say if the DNS protocol was not there, how would you know about the IP address? Maybe manually somebody would have told you that, okay, google.com web server is behind this IP address, right? So can you access the google.com server using IP address? Let's try it out. So I have done this NS lookup on google.com, and NS lookup is a utility which essentially uses DNS protocol to figure out the IP address. So it shows the IP address that this for this particular domain, this is the IP address. Now, can I access this Google server on this particular IP address if I just type in that IP address? As you can see, yes, I was able to access the google.com on that IP address. But what if the IP changes? Who's going to inform you about the IP change, right? In future, the Google server can move from one IP to another IP, then how would you know about it, right? So those were some of the challenges. So that gave birth to DNS. And essentially what DNS, in a DNS protocol, you would have a DNS server somewhere on the internet. Okay. And there are multiple hierarchies. I don't want to go there, but let's assume for simplicity that there is a DNS server on internet. Let's say the DNS server is on listening on IP 8888. That's the DNS server IP. And someone would have updated that google.com domain name is behind this web server or this IP address. So someone has updated this, and there are I don't want to get in the details of how this mappings are updated and so on, but for simplicity, for just understanding, assume that there is a mapping in the DNS server that this domain is behind this IP address. And what the client machine does is, using DNS protocol, it sends a request to this particular DNS server on 8888, and then the DNS server looks at the packet, sees, okay, this is google.com, and what do I have a mapping for it? Yes, it has a mapping for it. So it returns this particular IP address to the client, and then the client caches in this IP address, and if the request is immediate, then it's going to look at the cache and resolve it locally. If it is present, if it is not present, then the request will actually go out to internet, right? And so on. And there is also a cache expiry time, which is what we call TTL, time to live, uh, and so on. So let's see this in action, because in the first video we actually decoded the DHCP packets. So let's understand the DNS protocol using Wireshark packet capture. Okay, so let's do this. So in this video, oh sorry, in this terminal, I'm gonna run again TCP dump on my network adapter and save the packet capture in interface.pkf file. Okay, it's listening. And on the other window, what I'll do is I'll issue this request for this particular domain, but this time I'll change the server to 8888. Okay, so as I've changed the server to 8888, look at this, that you receive a different IP address, because Google server is available on multiple IP address. So this time you receive a different IP address. Now what I'll do is I'll stop this packet capture on the first window and then decode this packet using Wireshark utility. So if I go here, open the file again, then apply the filter DNS, So you will see that I see two packets. One is the request, and then there's a response. And the request is from my client machine, which is 192.168.1.6. Destination is 8888. This is the this is the DNS server we specified in our query. And if you look at the DNS protocol fields, right, there is a query field, and it says give me the IP address for domain name www.google.com. This packet is actually sent to server 8888, and the server is listening on port 53. Okay, this is typically the DNS server listens on port 53. And when you receive a response, you would see that there is a response sent from that particular server to your IP address, and then it's gonna say that in the answer field that www.google.com is reachable on this particular IP address. So that's how it is. Like, you configure a DNS server, you send the DNS query to that particular DNS server asking for a domain name. If the domain is present, it's going to reply back with the IP address for that particular domain. If I try some invalid domain name, let's say for example, uh, mm, XYZ, so the DNS query will fail saying that the domain name is not even available. Okay, so that's all it is to a DNS protocol at high level. Um, I hope it makes sense. And in the next video, I'm going to cover ARP protocol. See you there.